Hello and welcome to Autodesk University 2020 and today's Trimble SysQue for Electrical presentation. I'm Doug Elliott, your SysQue product manager, and joining me today will be Judy Miller, our VDC software sales engineer, and Ron King, our Trimble MEP global estimating manager. The team wishes they could do a deep dive presentation for you on Trimble SysQue for Electrical, but due to today's format, we're going to have to keep it a little bit more short and sweet. So our agenda for today is we're going to do a quick product introduction. Judy Miller is then going to demo us on how we find and utilize building data content in SysQue, and then how we utilize our electrical settings and project data to be productive. We'll then roll into some of our new features around Conduit 3 and 4-point saddles. And then Ron and Judy are going to show us how we can model that conduit and those bends in SysQue, take that to the shop or the field, and easily bend that and install it. Why SysQue Electrical? So SysQue Electrical empowers your detailing team to work with the engineers and the fabricators in the shop to build constructible real-world models inside of Revit. So as you know, inside of Revit, the content is generic, and what Trimble Building Data brings, as of today, is about 4.9 million items from about 63 manufacturers, and that's growing daily, of content. This is geometrically correct, dimensionally correct. It comes with a PDF attached to the content, so you can pull that up. You can easily create submittals, which we'll look at the next slide here. And the great thing about this is you ask for the content, we build it, and we maintain it for you, and we test it. So some of the new features we have in our latest release of SysQue Electrical, like I mentioned, were the 4-point and 3-point saddles, and we'll take a look at those here shortly. We've also did some work around our reducing fittings and the ability to push parameters through contents to keep track of your vital system parameters, where something's coming from, where it's going to, what's inside of it, and such. Some of the other value propositions we have for SysQue is our cable tray, which is, like I mentioned, dimensionally correct. It comes with clearances, dividers, covers, splices, and everything is manufacturer driven. So in SysQue, we have powerful electrical specifications that allow us to generate wire fill reports, panel and circuit reports, and our specification driven workflows. So you change the spec and everything updates for you in the model. So along with what you get for the electrical functionality, you also are able to do supports for your MEP hanger needs. You can lay out points for exporting out to a Trimble total station or any other robotic total station. You can quickly package submittals. Like I mentioned, all of our content comes with PDFs attached to them. You could package that up in a submittal package and send it out the door in no time flat. We also have expanded our spooling functionality with our spooling 2.0 in the last few releases. And then we also have Trimble Connect that's included with your SysQue subscription for project coordination. So it's not just about SysQue Electrical. SysQue has pipe and duct in it as well. So it's your one-stop shop for being productive inside of Revit. Judy, hand it over to you.
Okay, can you see my screen, I assume?
We got you.
Cool. All right, so we're going to start at the beginning and building data. Building-data.net is the website, and you can certainly go to that if you're not a SysQue subscriber today and take a look at the content that we have here. As Doug said, it's based on users' input or users' requests, and you would just come up here and request content if we didn't have it. But you can go through the catalogs here and see what's available. When you come to a catalog that you're looking for or a manufacturer, you can sort by a product line or you can look at everything. So if we just came to one in particular, you'll see the pieces and the parts that are available. And then next to that is a PDF of the catalog that was used to build content. So the content is built dimensionally correct, and we'll talk about that in a little bit when we get to specifically with tray. And that PDF also comes into play again within SysQue itself. It's hyperlinked to the family as well, and everything is version controlled. All right, so let's jump into the model now. So our pallets here are set up again with those manufactured pieces and parts. Now, in the case of Conduit, you know, maybe you don't know what you're buying, or maybe you really don't even care. But the point, and you can use any EMT or rigid intermediate, aluminum, PVC, MC cable, we have them all. You can just select one then and not necessarily report on the manufacturer. You can just report the fact that it's EMT. Okay. So, I wouldn't get too bogged down on the fact that, oh my God, I don't know what I'm buying for conduit. The point of the electrical settings is telling the SysQue how often to break that conduit and put couplings in there. All right. And you don't have to do this when you initially draw. You can do it later on. Service type is a feature to allow us to define the service type in the service type parameter, but also assign colors and create filters for you so that you can see on the screen clearly what it is, right? I mean, I can look at the screen and say, oh, okay, I've got branch power in here, or maybe I'm doing a fire conduit. So I can define the service type, I can define the color. We have some predefined colors, but if you want to come in here and just, for the case of fire, make it full red, you can do that as well. The 360 here, you can change this value. What it's doing is when you're modeling your conduit, SysQue is going to use that and count your bend angles within a run and report back to you only if you exceed this number. All right, it'll also show up in wire reports, but while you're modeling, it's going to tell you if you exceed that number. Down on the bottom here is the bend radius and lead lengths, and these are based on the Greenlee benders. So the triple nickel in the case of 2-inch and less, and the 881 for 2.5 to 4 in the case of EMT. We have the same table for rigid as well. So you can edit these values. Obviously, if you're using a different shoe, if you're using a different bender, you can certainly edit these values. But what they're doing is, again, when we're modeling our conduit, it's looking at these values to put in the correct bend and the correct leads. So it'll tell you if you try to kick that too tight, basically. What it also means is, when you're modeling, now you're modeling with correct dimensions. So as far as taking it out to the shop and installing it in the field, you know that conduit's going to fit in the correct place. An additional option that we have here is project data. And what that feature is meant for is that you can add additional parameters to your conduit fittings, couplings, whatever it is. And in this particular instance, I've created 2 parameters, to and from, and I want to push those through my conduit, which means, and I'll demonstrate that, is when I add those values, define those values for a run, and then right-click and continue drawing or modifying or rotating or even trimming, it's going to continue to push those parameters through your conduit. You're not going to lose that data. The third option is to put in a UPC number, and that's what I did in this case. It's obviously a different number for each pipe size, so that's going to also report. And I'll show you the benefit of that as well. One of the things that you don't see in this dialog box, but if you assign wire to your conduit, it's also going to check and make sure that you don't exceed 40% fill. So multiple options there, multiple settings that we can take advantage of. One of the new features to do with this latest version, version 8, is the 3-point and 4-point saddles. And on my palette, you see that I have 4-point machine in hand and 3-point machine in hand. And again, we have those for both materials. So Doug, if you can show the video that we put together, it's a 2-part video. One is me showing it in Revit and creating the spool drawings. The second part is actually confirming with bends in the field how they go together and that they fit exactly as we just define them to be. We approached the column, I ran through the column. Of course, we can't do that with the conduit, so we're going to have to put a 4-point saddle in there. I dimensioned, so I let SysQue place my couplings for me. And again, if as a review from earlier, we've set this up to place couplings every 10 feet. So that's where that came into play. So I dimensioned to my coupling. Now, obviously, I don't want these conduits to go through my columns, so I'm just going to delete those two. But I knew that my dimension from the face of the column, and I can re-annotate that to the inside of my coupling. Okay, and again, our families have that engagement filtered into the, included into the family or modeled into the family. All right, so 33 and 5/8 by 18 and 3/4 by 8.5. Those are the dimensions we need to remember in order to put those offsets in. All right, so in our palette now, like I said, we have a hand bend and we have a machine bend family. And when I go to edit this to show you, here's the hand bend. Here's where it's going to put the marks. The values that I have in here are based on the Klein hand bender. So we would start from the center and work our way out in both directions. The second one, again, is the machine bender. And the values I have in my tables here are based on the Greenlee triple nickel. Again, your marks are in a different location in this scenario because we're going to start from one end of the conduit and continue to bend through to the end. In my 3D view, I want to come in and place my machine bend. So I'm just going to connect to that coupling. It inherits the elevation and the size that I've run previous to that. And of course you see that it came in, but it's not looking right, so we'll have to make those adjustments based on our values here. While I'm at it though, I'm going to place my hand bend in there as well. And you notice that we're a little short on this side. So first, we're going to look at, again, the machine bend. So the machine bend is telling me I'm using a 7-inch radius bend, and I have my lead length and my lead out length and my take up values in here. So let's work on the dimension column category. So we're going to say 33 and 5/8. And that's the distance from the edge of the column to the end of the conduit. And then for my height, I'm going to say 8.5. And for my width, I'm going to say 13.75. And I don't have to do anything with my rotation angle. Okay, so you see that it wraps around. We're looking at the first one here, which shows the center line. It wraps nicely around the column based on the values that I gave it. Okay, so let's do the hand bender. So again, values are set up here based on the Klein bender that we're using. Again, it includes the material as well. So I'm going to put in those same dimensions. So we're looking at it now in the plan view and in the ISO view. Notice, and it really shows in the front view, is that our conduits now don't, or our couplings don't align to the couplings that were placed previously when the conduits ran right through the column. And that's because we took that 10-foot piece out, and with bending it, we have shrink in there. That's why you see a gap in there. So we would just simply take that conduit and move it into the end of our offset family. So now we have our conduit nicely going down the wall, around the columns, and continue on. Well, let's take this out to prefab now. Let's create spool drawings and be able to take this out to the shop and bend it based on our value. I'm going to open up SysQue and I'm going to open up the prefab manager. I can close our electrical palette now. I've already loaded my template, and we provide that template to you as part of SysQue. It has templates for cable tray, conduit, pipe, and duct. So I've already loaded my template. I'm going to create this as a conduit using the conduit template. So I'll select my first option here, or my machine bend, create a spool. I'm going to give it a prefix and a drawing number. So it listed over here in my dialog box. The second one, I wanted to maintain that same prefix, but it's going to automatically number it to number 2. So once I'm done creating my spool drawings, I'm just going to click on Generate Sheets here, and it's going to go out and create my sheets and views and schedules. So let's take a look at those. So the first one we have here is we have our schedule. Our schedule is going to tell us piece number, got our bend angle, we have our bend radius, we have our conduit end to edge of obstacle, we have our height, our width, we have what it is. So it's a EMT machine bend family. Mark A, B, C, and D. So we can go out to our shop, put a tape measure on a straight piece of 10-foot conduit, mark these values, and start bending from those marked numbers. Also gives us our conduit finish length, but we're going to put all these lines or marks on the straight piece of conduit before we start bending it at all. Again, our that is to just simply come down here. We're going to select both of our conduits or both of our spool drawings that we've created. Down here, I'm just going to say, create me a PDF. I'm going to say combine them into one spool sheet so I can just send one file out to the shop to be built.
Good afternoon. Hey, we're here to demonstrate. We've ran a 1-inch EMT conduit along the wall, and I've got an obstacle that I'm going to need to have a 4-point saddle to go around that obstacle. So a couple ways to do this. Conventionally, what we would have done is we've got to do some math to figure out where our bend marks are going to be on our conduit in order for us to properly bend the conduit and for it to fit. So the particular obstacle that I'm trying to go around, my 4-point offset, this is 8.5 inches deep by 13 3/4 inches wide. So we'd have to do a little bit of math. I got to know what my bend angle is. And an easy multiplier to remember is if I'm using a 30-degree bend, my multiplier would be 2. So it's pretty simple to go 8.5 inches times 2, 17 inches. That means the distance between my two bends needs to be 17 inches. If I'm going to use a 45-degree bend, then my multiplier would be 1.4. Then I'd have to take 1.4 times 8.5, and I don't know, I'd have to get my calculator out to do that. It happens to be 11.9 inches, but I couldn't figure that one in my head. The second thing that we need to take into consideration is the shrink of the conduit. So if I'm doing 30-degree bends, my conduit shrinks 1/4 inch for every inch of obstacle that I'm getting ready to go across. This being 8.5 inches high times 1/4 inch, that means that my shrink is going to be 2 1/8 inches. So I'd have to do that math to properly lay out the marks on my conduit and then bend it for it to fit without having it being too short or being too long and having to cut the tail off. What we've come up with is a SysQue way. So if this is modeled in SysQue, we could absolutely fabricate this in the shop so that it would fit like a glove in the field. The way that that works is we've created 2 different families in SysQue, 4-point bend families. One of them is a hand bend family. The second one is a electric or machine bend. It's going to use lookup tables, and those lookup tables will tell it for the type of conduit it is, EMT, the size it is, 1 inch, what my bend radius is. And in this case, on the 555, it's 7-inch bend radius. We have drawn this in SysQue. I'm going to export out a spool sheet. That spool sheet I would then send to my fab shop. The fab shop would literally put the marks right on the conduit, put it in the bender, and bend it. So I'll demonstrate that. We'll go to the shop and we're going to do a couple bends. I'm going to do a machine bend and we're going to do an electric bend. And then we'll bring it over here and see if it fits. All right, we're here in our makeshift fab shop. I'm ready to bend using our SysQue spool sheets. I'm going to do a manual bend and an electric bend. Show you how simple this is, no math. Okay, so out of SysQue, we mentioned a minute ago that the modeling will have the conduit run already in it, and from there, all I have to do is print my spool sheets and then can go to the fab shop. So the first one I'm going to lay out is for our electric bender, and the spool sheet on it, the things that have come directly out of SysQue, it tells me that this is an electric bend, so I know I'm going to use the 555. It tells me exactly where to put my marks, Mark A, Mark B, Mark C, Mark D, using the push-through method through the 555 in order to bend this 4-point saddle. It also tells me the edge of my conduit to the edge of my obstacle. So that's listed there as well that I have. It also gives me my height and width of my obstacle. It also gives me my bend angle. That's important because I got to know, what angle I'm getting ready to bend it at on the 555. It also gives me my bend radius so that I can check that against what shoe I might have on the 555 just to ensure I've got the right one. And I'm using a 7-inch radius on this shoe. So with that, I want to demonstrate how simple this is because with this sheet, I don't have to do the multiplier math and all the stuff to figure out where those marks are going to go. I take it directly right off the sheet. So we're going to lay the marks out. So that one's ready to go in the bend. That's all all I had to do. Didn't have to figure any math or anything. Ready to go in the bender. While I'm here, I'm going to go ahead and put the marks on for the manual bend. Okay, that's all you got to do. Just put your marks on there, throw them in the bender and bend it. So we'll show you that and how fast this is. Okay, we're ready to bend this. Want to give a plug there for the plan group who graciously let us borrow their 555 bender for this demonstration. We're ready. We've got our conduit marked, and we're ready to throw it in there and show you how fast it is once this was marked and it's ready to be bent. Coming out of the bender, we've got our 4-point offset. The SysQue way, just laid out the marks, throw it in the bender and bend it. So I'm going to do a manual bend, show you the same process, and then we're going to go put them in and show you how nice they fit. Okay, now we're ready to do the same SysQue way using a manual bender. Thank goodness I ate my Wheaties this morning because, yeah. Okay, so let's get going. We've already laid out our marks on here. I told you I laid them out in a different sequence, so my mark A is actually my second mark that I'm going to do. And then we're going to flip it around in the bender to bend the other side of it. There's how we laid out our conduit on a straight run. Now let's go put these in, see how they fit. Okay, we're back over here, ready to install our 4-point saddle. I'm going to do the machine bend one first and then the manual bend after that. But to show you how well this fits, it should fit. Okay, so we're going to shove that into the coupling. Look at that, no math, and it fits like a glove. And now I'm going to show you the manual bent one. Again, you know, just threw the marks on there coming off the spool sheet. I'm going to shove it home in the coupling. It fits like a glove. You know, so this just shows you how easy it is if you do your drawing or your modeling in SysQue and then export out the spool sheets. Send it right to your fabrication shop, no math needed.
We hope you enjoyed this video. Visit mep.trimble.com for even more product resources.